Good morning, everybody. I'm Martina Favarin, a researcher of the University of Venice. I'll present my project about smart monitoring and modeling to enhance the treatment and reuse of highway stormwater. Stormwater is a pollutant source due to the contamination from atmospheric deposition, leaching from buildings and guardrails, and traffic emission, resulting in the presence of suspended solid, heavy metals, that is our focus for now, and polycyclic aromatic hydrocarbons. The aims of the project are the development of innovative techniques for estimating and managing the pollutant load and the environmental impact of highway runoff water, the demonstration of the potential of passive sampler in the quality monitoring against the classical sampling option, and the combination of online sensor, passive sampling, and mathematical model to have information about both quality and quantity of the water. Just a quick overview about the treatment plant where I'm doing my sampling and monitoring campaign. It's along an highway called Passante di Mestre near Venice, which is 32 kilometers long, and it has 54 plants treating first flush runoff. The total volume of the plant is 9 cubic meter, and it has 3 filters with 1 liter per second capacity. This is the setup of the plant. When it rains, the water enters in the system, and thanks to our rain gauge, we can have real-time data about the intensity of the rain. So the water is filtered and discharged in the receiving water body after 30 hours. Online sensor give us information about the quality of the water, and if some parameters are out of specific range due to accidental spill, the water is diverted to an emergency tank. Thanks to passive sampler, we can collect the water from the beginning to the end of the whole process. So the water is collected in those bottles placed in the bottom of the tanks, which are previously filled by cartridge containing absorbing material. Then, thanks to level sensor, we can have information about the amount of water treated by the filters and the behavior of the level in the tanks. So the monitoring campaign consists of level sensor, multi-parameter sensor, rain station that has a rain sensor and a weather station, and passive sampler. So the available data are level data before and after the treatment, quality parameter data, rain data, and heavy metal concentration. With mathematical model, the aim is to quantify the pollution load and the concentration in the highway runoff, to evaluate long-term performances of the filters and the long-term quality of the water, thanks to historical data from a weather station near the plant, and to propose a better management of this kind of treatment plant, proposing different operational scenarios to maximize the treatment of the most polluted fraction of the water. These are the first results. We compare the rain data with the water level in the tank and the quality parameter data, in particular turbidity. And these are the first results from the chemical analysis. The data are based on the water amount collected in the bottles and the concentration found in the absorbing material, resulting in an average concentration during the whole rain event. These are the detected parameters by now, and from this data we can have information about the efficiency of the filters, and the aim is to compare this data with the quality parameter data. Further development can be done assessing the environmental impact to try to transform water flux in a new water resource, then to increase the knowledge about stormwater with the new sampling campaign, trying to find a correlation between concentration and dry and wet period before the rain, and move the technology to other locations. Passive sampler now are usually used for groundwater and water courses, but it's a very versatile technology. Thanks for your attention.